Okay, on to exercise 7, and I saw a lot of perplexed faces when they saw this one yesterday. So this one, you've got units that are dipping in two different directions. In some places they're dipping towards the east, and in some places they're dipping towards the west. So we've got two different dip directions like that. That confused a lot of people, but this is very similar to one of the examples that you saw in the prac last week. You had things dipping in two different directions. Same unit dipping in two different directions, so again we've got this repetition like this, and they're dipping in two different directions, so that's indicating that we've got a fold going on here. So this is a simple fold exercise. The next thing that confused a lot of people was here we have a dip at 26 degrees, and down here we have a dip at 14 degrees. So which dips do you use? Well, really here you would use it as the steepest dip, that 26 degrees. And the reason we've got this change in dip is if you think about a fold, a lot of people are drawing their folds like that, which is what I was trying to encourage you not to do last week. And if you had it drawn like that, everywhere along there, if you measure that angle, it's always going to be the same angle. And on the other side, that angle in there is also going to be consistent the whole way along. Whereas most of the time with folds, they don't look like a nice V. What they look like is a curve. So that's a much more common sort of shape for a fold. The thing about a curve is that angle to the horizontal is going to change along it. So here you've got quite a steep angle, and down here, this angle here is going to be shallower, and down here it's actually horizontal, and then on the other side, shallow angle followed by a steeper angle. So this might be 26, this might be 14, here it might be 0, then 14 the other way, and then 26 the other way. So that's what a fold looks like. So that's what this is indicating. You're getting closer to this hinge where it turns around. So it goes from steep to shallow to horizontal to steep the other side. So what that's saying is that this piece, this here, is on the same limb as this one here. You're still going down, you haven't actually hit that hinge yet. This one is on the hinge on the other way. So somewhere between those two, you've got that part where it actually turns around. So that's probably somewhere between here and here. So let's just make a rough guess and say that it's there. And like I said last week, it's always a good idea to draw your fold axial planes on maps. When you're actually doing proper maps, there's pretty much always guaranteed to be at least one mark associated with this. So that's just a hint. If you have a fold on your map, always draw the fold axial plane, because you're going to get a mark for it. If you don't have it in there, you're losing a very easy mark. So our fold axial plane is down here somewhere. Okay, so then we can draw a cross section. So the only other real difference between this one and most of the others that we're doing is, once again, we've got topography on here. So don't get confused, this is very similar to the earlier maps that we did that had topography. First thing you'll do, put your piece of paper along your cross section line and measure off where those topographic contours are along there, and draw your topographic profile. So that's really the first thing you do with geological cross sections. Always start with your topographic profile. In this case, it was a relatively gentle downhill sort of slope. It looks something like that. So again, I've drawn it quite roughly. You guys should try and keep it relatively nice and neat. Once you've done that, join your topographic profile, get another piece of paper or the other side of the piece that you've already used, line it up along that cross-section line again, and now you do the geology. So you put the marks on where you've got those geological contacts. So they're the geological contacts there. You transfer those marks onto your cross-section along like this. So there are geological contacts between the different units. Then you start trying to draw your cross-section. So I'd start off with the steepest angles that you've got written there, 26, 26. On this side I think it's 25 and 26. Again, just average those two. They're very similar to each other. There's going to be measurement angles associated with measuring these things in the field. So if you're seeing some at 26 and some at 25, pick one or the other to use. I think I've used 26 for both of these. So using your 26, and what I did, firstly, I got a ruler, and I know I've told you not to use rulers, but I got a ruler and ruled down a line at 26 like that and like that. I ruled a line on the other side that went down at 26 like that and like that. And I just use those lines. So I just did it very lightly in pencil. I just use those as a guide for my fold. And then I just try to draw it around like that and around like that. So it's going to be 26 degrees at the surface, but as you get down to depth, you start to deviate away from that angle because you get closer towards that fold and things start to bend around. It's to be said before, you go to 14 degrees, well, really, you go from 26 to 25 to 24 to 23, all the way down to 0, and then you go back up on the other side. So that's how I drew it. I drew my lines, and then I simply tried to draw curves in there. So there is a little bit of, I guess, geopoetry involved in this. You're fudging it a little bit, but really this is, remember, a model based on the data that you've got. You haven't got 100% perfect data. You've only got a limited data set to deal with. So do it as best you can with the information that you've got. Don't contradict any of the information that you've got, but try and make a model that fits with every piece of information that you have, and you don't have 100% of the information. So that's what you're trying to do. So I drew my fold in, and really what I want you to try and do as best as possible is try and keep the thickness uniform throughout that fold. So when you're drawing, especially when you're curving around here, try and keep that thickness, and I haven't done it perfectly myself, but as I said, this is a pretty rough sketch. This thickness here should be the same as that thickness there, should be the same as that thickness there. So do it as best as possible. Ideally, you should be using a pacer or a mechanical pencil with something like a 0.5mm lead, so something relatively thin, and try and draw this as precisely as possible. I only had a 0.7mm lead pencil in my office, unfortunately, so these lines are a bit thicker than I'd like, and they're a bit messier than I would really like. But try and keep yours as neat as possible. So then the other thing you did, you had one little bit of unit over here as well, so draw that in. And then what I do is I'll draw in my fold axial planes. These should always be on your cross section. Again, I guarantee there'll be a mark associated with these in the assessment if there's a fold in there. So make sure that you always have fold axial planes or any important structural information drawn on. Draw your fold axial plane and just put the right symbol on it. So in this case we've got a syncline, so I've drawn it like that. Remember, syncline, so you've got that sort of shape, or anticline is that sort of shape. So A or Y, in this case we got more of the Y shape, so this is syncline. There is also an anticline on the map, and it's really common to get these folds going along like that: syncline, anticline, syncline, anticline, syncline, anticline. So here we also have an anticline, and we know that because this guy is dipping towards the west. This one here is dipping towards the east. So somewhere between those two we have another fold axial plane. That's our anticline. So I drew that in there, drew my anticline symbol on like that. And what I also would really encourage you guys to do is just to do dashes above ground to show what that structure looks like that, like I've done on there. So you don't need to color this section in. You don't really want to do it as a solid line because this material no longer exists, but it's just showing what that structure of the area is. Now, these folds are really commonly associated with ore deposits. Nancy might talk about this a little bit in her part of the course later on in semester. But especially anticlines, you get fluids moving up these things, and they often pool in these sorts of areas, and that's where you get quite a lot of precipitation of minerals like gold, which can be quite important economically. These also form traps for petroleum, oil and gas sorts of deposits. So these sorts of structures can be extremely important in geology. So you want to recognize them, and you want to make sure that they're marked on your map and on your cross section because they're very important. Again, like all your cross sections, title, make sure you go to scale, make sure you go to key. Remember, always have your key in stratigraphic order. I haven't done the geological history for this one, but it should be relatively obvious to you that this unit's at the bottom. So these were the silts. So silts were deposited, then the clays were deposited, and then the sands were deposited. They were buried, they were lithified, turned into siltstone, claystone, and sandstone. then you had them folded, and then you had them uplifted and eroded to the present day land surface. So that would be your geological history for this area. So when you're putting together your key, make sure that your key is in that same order. So the silts should be at the bottom of the key, then the clays, and then the sands at the top of the key as the youngest unit in this area. So hopefully that's all fairly clear to you. Just one last point, I guess, to make is when you are measuring these angles in here, always measure them to the horizontal. So this land surface is sloped, but what you want to do is measure that angle to the horizontal. So don't measure them to the land surface, measure them to that horizontal. Same with over here, you want to measure the angle to the horizontal, not to the land surface. So just be wary of that. Some people got tripped up by that yesterday. Just make sure that when you are measuring those, you're always measuring them to the horizontal. Remember, those are measured based on the strike line, which is what would happen if you put a spirit level on the rock. So they should be measured to the horizontal, not to the land surface. Okay, I'll leave that one there. Again, if there are any questions, just post them in the forums, and then I'll move on to